right. So the decimal point is moving around the digits. It is possible. Are you clear? Are you clear? In a fixed point representation, your decimal point is fixed location. But here it moves from left to right. Left to right means decimal points are moving to the fraction side. Right to left. Decimal point moving from fraction to decimal side. So this movement is possible in a fractional point representation. Binary point is also called as decimal point. Do it fast. Binary point is also called as decimal point. The position of the decimal point is fixed. మనం ఫిక్స్డ్ పాయింట్ గురించి మాట్లాడుతున్నాం. Yeah. The position of binary point, the position of binary point is not at all fixed. The position of binary point is not at all fixed. The point floats around the digits. The point floats. Floats means moves around the digits. There is no fixed number of integer digits and fraction digits. There is no fixed number of integer digits and fraction digits. In fixed point representation, there is a fixed number of integer digits, the fixed number of, but here your decimal point moving right, left to right, right to left. You cannot tell fixed number of integer digits, fixed number of fraction digits. Floating point numbers will be representing with a scientific notation, with a scientific notation that is m into r power e. M into capital M into r power e. We are going to represent our fractional point representation with help of this notation m into r power e, where m represents mantissa, m represents mantissa, e represents exponent. And r represents, tell me, power. Base power, otherwise. Power base or power of base, otherwise base power will be right. Power base. So for example, just observe, for example, if you take one number, how to represent? As per the scientific notation, 1011.011. Okay, this is one example binary number they are given. So how to represent as per this fractional point representation? If you want to represent this number, so how many digits are moved from left side? So this is a mantissa into 2 power. How many digits? 3, right? Or even, no sir, I want to move this into that side. Decimal point moves to, this is right side to left side. So the power may be positive. Are you clear? Correct only, right? You know how to write already. Then right to left means it should be a negative power. You will get. For example, 1011.1. How to write? 2 power minus. Correct? Is it right? Is it right? So this is the representation of floating point. Are you following? Okay. Then if you do like this, there is a problem again. What is the problem? I will tell you. You take one example, same example you consider here. What is that? 10110111. So you can represent same number with the help of fractional point representation. Are you following? So for example, you can write 101.1011 into 2 power 1. Yes or no? 10.11011 into 2 power minus 1.011011 into 2 power 1011 0.11 into 2 power minus 1. All these are possibilities. Yes or no? As per the scientific notation. Correct? 101101.1 into 2 power minus 2. Then all are correct. Yes or no? So if all are correct, again this is a problem. Why? Our mission is which is going to consider out of this. Fixed point, there is a no problem because very clearly you told after decimal point how many digits are for fraction and before decimal point how many digits for. But here there is confusion because here we can use the scientific notation and you can perform. So whatever the way you can perform, all are correct. Then which we are going to consider. Again, it is a conflict of the mission. Mission always expect only exact instruction. Yes or no? So there is a confusion. Sir, how it will be confused, sir? Anything you can understand? Yes, understand. For example, whenever you are working with the mission, sometimes you are given this notation. Okay? After some time, for other expression, you are given this notation. Again, conflict will be start. For one problem solution, you are given this way. Okay, dude. Next time, I don't want to give. I will give only follow this. But mission, they can take this also. Again, there is a conflict. So, we should give exact information to avoid this problem. Are you clear? Problem is clear. Our subject completely numbers, circuits, no theory. So problems, you should solve many problems. That is why we need more time. Are you following? So some time I will give some exercise and some problems and maybe some speed also there. Please adjust. If anything is there, you ask. Got it? Yeah, tell me. Now to avoid this problem, problem is identified, right? So we need to solve this problem. Means we need to provide only one set of category of the instruction to the mission. Are you clear? So for that, you got it problem right? For that, to avoid such problem, apply the normalization technique. Apply the normalization technique. So you can learn normalization in database management system, 3rd unit. So don't think that this is same. That normalization of meaning is same. Why meaning is same? Normalization meaning is to avoid the redundancy. What is the meaning of redundancy? Duplication of the data. That is the redundancy. In a relation, wherever the duplication of the data in your DBMS, so normalization one, because of the normalization only database management system is implemented actually. So apply the normalization to avoid the redundancy. Meaning is same terminology to avoid the all are same, right? That is why duplication we should remove. So that is the meaning. So overall concept you can understand same. If you understand now, you can apply in your database management system. Are you clear? Complete third unit. So normalization. Apply the normalization means we need to find the solution, best solution to avoid the redundancy. Normalization is used instead of using multiple types of position representation. Instead of using multiple types of position representation, right? Multiple types of decimal point position, decimal point position representation. Use one fixed position representation. Fixed point, fixed point means another technique, right? Fixed position representation. Please try to understand the terminology. Fixed position representation, because here we have different position representation for fractional part representation. Are you clear? But in this different point, it is a redundancy, complexity to understand the mission, which is correct, which is wrong. Confusion, yes or no? So to avoid that, the normalization is going to tell to fix only one fixed position representation for the fractional part representation. Got it? That is before the decimal point, before the comma, the decimal point moves to left side from right side. Left side to left side from right side. Right side నుంచి left side move అవ్వాలి. Yes or no? Must be a non-zero number. Must be a non-zero number. For example, 10, same example, 1011.011. This is a number. To avoid these many confusions, apply the normalization. Yes or no? What is the normalization? Your decimal point must move to the left side until non-zero. So what is the non-zero? 1. Leftmost is 1, right? Then how to write? 1.011.011. It was moved how many digits to left side? How many digits? 3. Yes or no? Then what is the 2 power? Correct? So this is the representation. To avoid this problem, to apply normal, apply the normalization technique. So this is the representation for the given problem. Got it? One more example, then I will give it to you. Just do it fast. 111.01.110. Now represent in a fractional part representation. Fractional point representation. Tell me what will be the output for this? 1.11011110 into 2 power. How many digits are moved? 1, 2, 3, 4. Correct? Right. Okay, how to represent now? How to represent now? How to represent? So generally in your fixed point representation, the format is what? Sign number, integer portion, and fraction portion. Yes or no? This is the syntax variable. Here, what is the syntax? Again, same. Sign number here, exponent here, matrix. Sign number, exponent, matrix. What is the representation? Tell me. What is the sign number for this? So 0 represents positive. Sorry. 1 represents. Correct? This way you can write. So you can convert this. What is the exponent? Sign number is what? Here, what is sign number? 0. What is the mantissa here? So after dot, we can call it the mantissa. Yes or no? What is that? 1 1 0 1 1 1 0. Is the exponent kada? Sorry. Flow. So what is the mantissa here? 1 1 0 1 1 1 0 is mantissa. Then what is the exponent here? 4. What is the binary code for 4? Yes or no? What is the binary code? 0 1 0 1 double 0. Otherwise 1 0 0. So this is the representation of fractional point representation. Okay, happy. But there is a scope for negative exponent. Possibility there are not. Sometimes you will get negative exponent. Then if the negative exponent, how to represent here? Positive representation, okay. Because here we have written. Not like this. I am not telling about sign number. Sign number is for number minus or plus. I am discussing about exponent. Exponent. Are you clear? R power E, that exponent. Exponent, R is a base, right? E, what is the E? Exponent. We are moving from right to left, maybe you are getting positive. Maybe because of the number, there is a scope, you are going to move from right to left. So exponent may be negative. If the exponent negative, how to represent? Exponent positive, easy. Exponent negative, again problem. Are you following? First problem, multiple representation. To avoid, apply normalization. After applying normalization, your exponent may be positive, you use this syntax. Following? If the exponent is negative, there is no option, right? You should represent. Are you following? For the negative number, there is a sign. But exponent negative sign is where it is. There is no sign for the exponent. In this case, to avoid this problem, we should use first problem raskondi. Are you clear the problem? In the problem, if exponent is negative, we are not going to accommodate in the given this format. ఇదంతా రాసుకుంటారని నేను ఎక్స్పెక్ట్ చేస్తున్నాను. అంత నోట్స్ చెప్పడం అంటే కష్టం, టైం ఉండదు, సిలబస్ చాలా ఉంది. సెకండ్ యూనిట్ చెప్పాలంటే సెకండ్ యూనిట్ ఐ కెన్ స్టార్ట్ ఆఫ్టర్ దిస్, బట్ ఐ నీడ్ టు టేక్ 2 hours extra to finish K-map. K-map is not there in the syllabus, but without K-map, you cannot start the combinational circuit. For K-map understanding, you will take at least minimum 2 hours. Please, that is what I am trying to finish the syllabus. Please try to support. Okay? Yeah. Now, got it? The problem? Yeah, this is not for me. Everyone same problem. We are going to cancel some labs also. I am thinking on that. Yeah, tell me. Now, what is the problem? If the exponent is negative, where we are going to accommodate the negative portion in the given format? It is not possible. If it is a positive, use this. Over. Your answer is over. As per the question, your answer is over. But the question, maybe it will be generating negative exponent. Then what should we do? So this is the problem. To avoid this problem, we should use biasing concept. We should use biasing concept. What should we use? You should add your biasing with exponent. We should add your bias with exponent. When we should add? When you will get the negative exponent. Are you clear? Sir, what is this bias? Bias means extra. Anything you can consider, anything you can add to avoid the problem. Yes or no? That is the bias. Actually, practical is there, it will be very clear actually, but there is no practical. Okay, so one example we'll check it. 1 1 0 1 0 1. This is a binary number. So show the fractional point representation. Huh? What is the fractional point representation? Tell me. Huh? Same example I am continuing. I am not changing my strategy. What is the 1.10101? Apply normalization. 1.10101 into 2 power. How many bits? 2. So 2 power 2. Now, if it is positive, negative also, we should add the bias so that no problem. Anything is there, it is not a problem. Then how to do? So same thing. What are the 3 fields we should consider here? Sign, exponent, matrix. Correct? So, you know, this is a, already you know this is a matrix. This is a exponent. Yes or no? Sign, exponent, matrix. Okay, you know already it is a positive number, you will write 0 here. If it is a negative number, it is generated negative number, you should write 1. Okay? That is, you know very well. Clear? So, as for this, 0. Then exponent and matrix. What is the matrix? This is also clear. Now, think about exponent. Why we are discussing exponent? Exponent is maybe the negative. Again, there is a problem. Exponent is positive, not a problem, we can accommodate. But we need to find ultimate one solution for whatever the problem. Are you clear? So to avoid this problem, you can consider your bias. Something you can consider whatever the number you want. I am taking bias is 8. For example, consider bias is 8. So for this exponent, what we can write? Exponent plus 8. What is that? Exponent plus bias. What is that? Exponent 2 plus 8. How much? 10. Are you following? So now you consider your U value as a 10 instead of 2. So what is the binary number for 10? 1 0 1 0. This is the representative. Sir, how it will work? I will show you the formula. The formula for this, minus 1 power s into 1 point mantissa into 2 power exponent minus bias. So this is the formula you can apply, you will get the representation. See this. What we have written? Sine is 0. Mantissa you got from your conversion, and exponent what you have to done? Bias plus exponent. Yes or no? So that is 10. So 10 representation is 1, 0, 1, 0. Just apply. You are getting same or not. Now what is minus 1? Minus 1 power s. What is s? Sine. S is nothing but your sine. How much? 0. Then 1 dot. What is m? Mantissa? 1, 0, 1, 0, 1 into 2 power. What is exponent you have taken? 10. Right? 10 minus, what is the bias? 8. Now check. This is, so 1 into something? 1 dot 1, 0, 1, 0, 1 into 2 per 2. Same number. Are you clear? So this is what bias you should use so that you can avoid the exponential problem. Are you clear? Please. Got it. Now this is a fraction point position. Clear? Whenever you are going to do fraction point position, you can move your decimal point from left to right, right to left. But the two powers are going to vary. Yes or no? To multiple representation, you should find one representation with help of normalization. Steps I am telling. After applying of the normalization, you fix one position. What is the position? Leftmost non-zero number. You should find the left side. You should find the decimal point. Are you clear? That representation you consider after applying of the normalization. After applying of the normalization, maximum problem is solved. But still, the r power exponent may be positive, not a problem. If it is a negative, then again we need to work on with bias. Are you clear? So the formula, you know, the bias you can use. So the number is negative, positive, very simple. If it is a negative number, you can replace 0 with 1. Okay? The syntax is same. Sine, exponent, mantissa. Are you clear? Are you clear? Please. And one more point also you should remember, always whenever you are going to consider mantissa, that is after 1 dot you should consider mantissa. Don't write 1 dot. Following? Please. Okay. As per that, our first unit syllabus is completed. But coming to the second unit circuit implementation. One is, first portion is combinational logic circuit. Second chapter is sequential logic circuit. This is your syllabus. But when you want to develop a circuit or design a circuit, there is a steps. There is some steps. We should follow that steps. Everyone should follow those steps. In that 5, 6 steps, fourth step, I think fourth or fifth step is to convert your input into K-map, Kernoff map. So that is there, that is not there in your syllabus. But without K-map, without Kernoff map, we cannot convert the data. We cannot design the logic circuit. So for that, we need some extra time to finish that. So are you clear? And this K-map implementation is very important in GATE examinations and competitive examinations. All competitive examinations, they are going to ask K-map. And not only this unit, second unit completely you depending on K-map, not only second unit, even in further units also, K-map is going to play a vital role. That is why without complete discussion of K-map also, we can cover combination circuit. Only whenever the problem will come, I will tell. But you don't have that much clarity because here more problems we can expect in the examinations, competitive examinations. Maximum questions come from GATE for this subject. And problems. And if you understand K-map is very easy. If you understand K-map, designing of the circuits are very easy. Whatever the question they will ask also, you can answer. Are you clear? So that is why please try to support to do this Karnoff